Hi, thanks for watching. My name's Hillel. I'm the co-founder of Invoice Ninja. I'm also the developer behind the Flutter Redux starter. I had made a very short video, kind of quickly reviewing how it works. I thought it might be helpful to make a longer video going into more detail, kind of explaining how it compares to other choices, why you might use it, how it actually works, and also how you can extend it. So to start, I think the first question a lot of developers building Flutter apps are asking is how to manage their state. And it seems like there are two main choices. One is Redux and the other is the block pattern. So in trying to understand the differences, I found it really helpful to compare in the React Native world, MobX versus Redux. To me, they have very similar differences. So I found this is a really useful article. I'll put the link in the description. So just to quickly kind of run through the differences. So with Redux, you have a single store, and with MobX or with block pattern, you'll have multiple stores. With Redux, you'll have plain data. In practice, with Flutter, you use built value. Whereas with the block pattern or MobX, you're going to have observable data. And this in practice has a big impact on the difference in implementations. So with Redux, any change to the store will update all parts of the app that are bound to the store. Whereas the block pattern, each individual part of your widget tree can bind to an individual property on your block and then update individually. So there are two things to consider. The first is by lifting your state higher up in the tree, you'll find that you're creating far fewer stateful widgets and in general creating a lot of stateless widgets. And if you're using const constructors, Flutter will behind the scenes cache that. So even though you are calling the rebuild, it's not really getting rebuilt. It's just reusing the widgets from the cache. Additionally, with the Redux Flutter library, you can tell it to just update parts that have changed, and you do that by setting the distinct flag to true. Then you also have to set an equals operator for the view model, and the solution there could be to use built value to automatically create the code for you. So just to come back to the end of this article, this author's conclusion is that MobX or block can be better if you want a faster development cycle or if it's for a smaller app, whereas Redux might be more appropriate for a larger app. And I've certainly found that to be true, and I found Redux in particular with immutable state to be incredibly helpful to manage application state and make the app state predictable. That all sounds great. What's the catch? I think most people would agree with Redux the catch is the boilerplate code that's required. I'm spending most of my time building the Invoice Ninja mobile app, and our app has many different modules, clients, products, invoices, etc. And all of these modules have a very similar fundamental function, right, where they have CRUD functionality. You can list the invoices, you can create one, you can edit one, etc. And so rather than have to copy and paste the code between each module, I wrote a simple shell script which takes one module and then creates other modules from it. And that's what's become the Flutter Redux starter. So the Flutter Redux starter, I'm going to switch to the code. The project can be considered in three parts. The first is when you initially check out the project, you're getting kind of the base Redux project, which includes the dependencies that you would typically need for a Flutter Redux application. And then it also provides authentication and persistence. So persistence is one of the big challenges we faced when developing our application. The problem is a user could have thousands of clients or invoices. However, we want to constantly save the state as they're making changes while creating a new invoice or editing an invoice. And so the solution we're using is to separate the store when persisting it to separate parts. And so that way the UI part is very small and can be saved very frequently, whereas the data part is very large, is saved infrequently. And that gives us kind of best of both worlds. So that's kind of part of the project. The second part is the starter script. And I think I'll quickly just run through it just so you can understand what it does. And there are two modes, init and make. So when you run it in init, it essentially remaps the project to your company name. And it's just a few changes to the code to do that. For example, in the Android folder, has to change the directory to com to your directory. And then the other place it would change is just the names. And then it also updates the stubs that come with the project to match your project. So the inits just run once, and it just uses sed to make those changes. Then when you run make, what it does is it initially will create directories to store the new files you're creating. It'll then run through each of the files and copy them over from the stubs folder to your folder or to the new module folder. And then it uses set again to run through the app and plug in the connections that are needed to wire up the new module to the existing code. So for example, if you look at the main Dart file, you'll see that top there's a comment starter import. What happens is when the set command runs, it uses this comment and says, all right, here's where the imports are for the main file, and then it adds the references that are needed. So for example, in the main file, it adds the imports, it adds the middleware, and then it adds the routes that are used. And then I'll show you in the code, you'll see the stubs folder essentially has a mini version of the main application folder. And we divide it up into data, Redux, and UI. The data folder will store your model classes, which are just built value objects, and the repositories, which provide the logic which is used to load and save the data. And then each repository could use a file storage and web client. File storage would be to persist locally, and web client would be to speak to a remote server. The UI is broken up by feature or by module, and so each folder will then contain the UI relevant to that module. And the Redux folder is then set up also by feature or module, and then each feature or module will have actions, middleware, reducer, selectors, etc. To wrap up, I'll show some ways you can extend what's created out of the box to fit your particular use cases. So, for example, you'll see with the Hacker News app, it's a pretty basic app where it has a list, and clicking an item will take you to see it, and you can edit it. If, for example, you wanted to change the edit view to add a field, steps are pretty simple. You would first go to the article model class, and in here you'd want to add the particular fields you want to add to the UI. Once those fields are added, you'd run the build script, which regenerates the model files, and then the Redux layer can be left as is. You just need to go to the UI layer and you go to the article folder, edit folder, and then you'll see it split between the edit VM, which is the view model, and the edit UI. And you just need to go to the edit UI and then add here, whatever text field or input you want to use to manage it. You then wire it up to the class, the changes that are generated, and that's it. It would propagate through the Redux store automatically, be persisted, and just work. So finally, I'll just switch to the Invoice Ninja app to show some ways we've used this base and extended upon it further. Some quick examples are, for example, sorting. You add additional sort fields, but then also additional filter panels, so you can show archived, deleted records, and filter by status as well. In our app, a user can have multiple companies. So if we open up the drawer, you see there's a company selector. And the way we manage this in the app is the app state itself is broken down into separate company state objects. Each are persisted separately. And so that means if you have many large companies, you can work in one company, save that data, and not have to resave the data for all the companies that you belong to. We've also enhanced the view and edit screens to match our use cases for invoices. So for example, for an edit screen, which is more complicated, we'll use a top-level view model for the page navigation, saving, in this case adding products and showing the total, and then each page or each tab has its own view model for its own logic. Finally, change tracking is something which can be very difficult to handle, but built value makes it very simple. And so what I mean is, in our app, if you're editing a record, we want to show an indicator that you have unsaved changes. So if I change the invoice number, you'll see then this lights up as yellow, showing that there are changes to be saved. What's nice about built value, if I undo that change, the app understands that we've now returned to the original state because it can compare the two objects. That's about it. I hope you found this video useful. If you end up using the library, I'm happy to help. Just have any questions. Thanks for watching.